In some of the problems in this unit, we're going to be asked to add or subtract expressions that have radicals in them. So what are the rules for adding or subtracting terms that have radical expressions in them? Well, in order to add or subtract things with radicals, the radicals must have exactly the same thing inside. If they're not exactly the same inside, then they're not like terms and we can't put them together. Then what do? All that we do, if they have exactly the same thing inside, if we want to combine them, all we do is add or subtract the coefficients of those radicals, which means the numbers that are out in front. Add or subtract the coefficients and then keep the radical along for the ride. So let's take a look at a couple of examples here. For problem 5, we want to find 3 radical 10 minus 15 radical 10. In each of these cases, notice that we have exactly the same thing inside the square root. They're both square roots of 10. So we can go ahead and add or subtract the coefficients, which are the numbers on the outside. If I have 3 square roots of 10 minus 15 square roots of 10, 3 minus 15 gives me negative 12 square roots of 10. And this is my simplified solution from adding those radicals together. In problem number 6, same idea here. I look inside the radicals. There's an x in this radical and an x in this radical. They're exactly the same insides. So because they have the same thing inside, they're like terms and I can combine them. So I add or just add or subtract the coefficients in front. If I have 3 square roots of x plus 9 square roots of x, I end up with 12 square roots of x. All right. When we come down here to problem number 7, I get a little bit concerned here. Notice here I have the square root of 90x squared minus x times the square root of 10. All right, well, what am I going to do in this problem? Right now, I have completely different things inside each of the radicals, so it seems like I would be stuck. Before you completely and officially declare yourself done with the problem, however, make sure that the square roots are in their completely simplified form, because sometimes when you simplify them, you will end up with values that you can actually combine together. And I think we'll find that's what happens here. Let's see. So to start with, I want to simplify the square root of 90x squared. So the first thing I want to do is let's deal with 90. 90 is 9 times 10, 9 is 3 times 3, and 10 is 2 times 5. Because I'm dealing with the square roots here, I'm going to go ahead and break this down into 2 square roots here. I look for any perfect pairs of numbers. So for example, here I have a pair of 3s. So 9 is going to go in the first square root, and then 2 times 5 are leftovers, and they go in the second square root. Then I look at x squared. X squared is a pair of x's, so that goes in the first group, and I can go ahead and take the square root of this first expression altogether. The square root of 9 is 3, the square root of x squared is x, and then I have the square root of 10. So my 90x, or the square root of 90x squared is the same thing as 3x root 10. All right, this is getting kind of messy. Let's go ahead and rewrite it. So the square root of 90x squared is 3x square root of 10 minus x square root of 10. And keep in mind, 10 can't be broken down any farther because it's just 2 times 5 and there's no repeated factors there. All right, so now I look here. I look inside the square roots and I have exactly the same things inside. So I can go ahead and combine these expressions. All I do is look at the coefficients. In this case, I have 3x minus x. Well, 3x minus x is 2x, and I still keep that square root symbol along for the ride. So in this case, even though they did have different things inside the square root originally, after simplifying the radicals, I came up with expressions that I was, in fact, able to combine. All right. Let's take a look at our last example here of some of these problems. When we start out for problem number 8, notice we have different things inside of the square roots. So I'd like to see if I can simplify any of the square roots first before I declare myself finished for this problem. In this particular case, I have 6 square root of 7. 7 is a prime number, so there's no pairs hidden in there. However, if I look at 28, I think you'll find 28 is 4 times 7. We see a pair of 2's in there. So we can actually simplify the 28 here. So here I have 6 root 7 minus 10. I'm going to break the square root of 28 down into my pairs and my leftovers. And then I can go ahead and take this square root here. The square root of 4 is 2. And now the 10 and the 2 are both outside the square root, so I can multiply those together. So 10 square root of 28 simplifies down to be 20 square root of 7. And now when I look at my expression, I do in fact have exactly the same thing inside of each of the square roots. So I can go ahead and subtract the coefficients. 6 minus 20 is a negative 14, and I have the square root of 7 that's left behind. Okay, and that's really all there is to adding and subtracting with square roots. Same exact thing as inside, add or subtract the numbers or values that are outside in order to get what your solution is. Keep in mind, if you have something like this, square root of 3 plus 2 square root of 2, you are done, and that's as much as you can do, for example, because here the values that are inside the square roots are completely different, so they're not like terms, so you can't add them together. It would kind of be like having something like x plus 2y. Different things in each of those values make them not like terms, and so you're stuck. So just kind of some examples. You will occasionally get weird looking answers like that, and that's totally legal and okay. But if you can simplify the square roots and end up with the same thing inside, then we can go ahead and get smaller, more simplified final solutions, which